We're now in Unit 7.2. Unit 7.2 talks a lot about proportions and similarities and whether shapes are similar to each other. But we're going to start out right now talking about ratios because we need to remember what those are. So a ratio is just a fraction of something to a fraction. If we're doing the ratio of juniors to sophomores on this, we can write the ratios as a fraction. Since juniors is the first word, we have to take the number that goes with juniors and put that on top of our fraction. So 520 out of 480. Again, juniors went on top, sophomores on the bottom. But then we have to reduce. So when I reduce this fraction, it becomes 13 over 12. We never want to leave these ratios as unreduced fractions. You can also write it like this: 13 with the colon to 12. And again, the juniors goes first because the juniors comes first in the sentence. So it's juniors to sophomores. Ooh, that's a sophomores. Solving proportions, cross multiply and divide. But if there's already something in our fraction that's an expression, you need to put it together in a package so that when we multiply by cross multiplying, we're going to do 8 times 2x minus 1. So we're taking this 8 and we're multiplying it by everything in the numerator. We're taking the 4 and multiplying it by everything in the numerator. And we only cross multiply when we have an equal sign in between. You can't cross multiply something like this. That doesn't work. This is a fractions that we're multiplying together. So you don't cross multiply that one. You just cross multiply when there's an equal sign. So this becomes 8 times 2x minus 1 equals 4 times x plus 2 plus 4. So this becomes 16x. Don't forget to distribute the 8 to the second term in that parentheses, minus 8 equals 4x plus 16. Subtract 4x from both sides, and you get 12x equals, add 8 to both sides, 24. So x equals 2. So we've solved the proportion. X equals 2. Okay, this is like everything you need to know about for this. And I want you to change of. So we're going to go from, put the word from in there just to make this a little bit more correct, and I'll explain this in a minute. Two polygons or triangles or squares or rectangles or pentagons are similar only if and if their corresponding angles are congruent and corresponding sides are proportional. So here's what this means. In this picture below, ABCD, this one, is similar to WXYZ, this one. Because those are similar, we use this symbol. The symbol is just the little squiggle. And just like triangles and being congruent, A corresponds to W. So you can tell right away from this similarity statement that A and W are congruent to each other. So angles are congruent in corresponding angles. So here's our statements for this picture. Notice again the A and W are in the same position in the list. And C is in the same position as Y in the list. So C and Y are congruent to each other. So angles are congruent, sides are proportional, corresponding sides. And you can notice that they're proportional also from this statement. So let's look at this. AB is the first two letters. WX are the first two letters in the other one. So we can write a proportion of AB over WX, or we can write it as WX over AB. You can write it both ways. So all of these proportions right here we can write together, or we can flip them over if we want to. And here's another thing about these proportions. If we're asked to solve something, we can take any two that we want to and write a proportion that goes with this. So I could write in a proportion that says AB over WX equals BC over XY and then solve it. Or I could choose to take this and put it with that. Now we need to talk about where that 3 over 1 came from. So AB is 15 and WX is 5. So this is 15 over 5. BC is 12 over XY, and that's 4. And all of these reduce to this 3 over 1. If we continued on and did it with 21 and 7, and then 18 and 6, we're still going to get 3 for each of these ratios or proportions, these fractions, that describe the relationship between this polygon and this polygon. So in order to be similar, the angles have to be congruent and the sides have to be proportional, meaning that if I do a fraction of all of the corresponding sides, I'm going to end up with the very same fraction for each of those. If you don't have that proportion number, if it's not constant all the way across, then the shapes aren't proportional to each other. Okay, the scale factor, we can calculate this. If I want the scale factor from ABC to triangle XYZ, pay attention to what comes first. So ABC to XYZ, this side right here is AB, right? And that's proportional to XY, 6 over 3. So I can get the scale factor from the big triangle to the small triangle by taking the 6 and dividing it by 3. And the scale factor then is 2. So that means that ABC is twice as big as XYZ. And if I go the other direction, then it's 1/2. So that means XYZ is half as big as ABC. So here's a congruency statement right here, or a similarity statement, excuse me. So we want to list all the pairs of angles. So I want you to try it first and see if you can do this. So list all the pairs of congruent angles and then write proportionality statements. So pause the video and then come back after you've made your attempt. Okay, did you get it to work? So A and R are congruent angles. That's congruent to, oh goodness, this should be RST. This should be R, S, and then T. Sorry, didn't notice that before. Okay, so there we have our proportion statement, and we're creating our statements about these two triangles. So ABC and RST are similar to each other because it has that little squiggle. So now we have to decide if the triangles are similar. If they are, then there's a similarity statement we can write, and then we can write a scale factor. So let's look at the angles first. So it's always angles first if they're available. I want you to figure out, pause the video and figure out what every single angle is in both of those triangles. All right, did you get 45 and 37? So these two triangles are going to be proportional if all of the proportions of the sides are the same. So let's start with the 37 with the small one with P. So in this triangle, if these are similar, P corresponds to U. And if these are similar, O, the 45-degree angle, corresponds to N. And then T corresponds to G. So we're going to write the similarity statement because we think that they're similar. So now that we have the corresponding angles matched up, now we can match up the sides, and the sides should be proportional. So PO over UN, again I'm getting this from the order of everything in the statement, OT should be proportional to NG, and then I have PT that should be able to make a ratio with UG, and all of these ratios should be the same. So from P to O is 9, and then from U to N is 63. OT is 3, and NG is 21. And then PT is 7, and UG is the last one, 49. So we can check this and see that if I reduce this, this is 1/7, this is 1/7, this is 1/7. So because the sides are proportional and the angles are all congruent, then yes, these are similar. Okay, and then we're going to look at the scale factor. So the scale factor from POT to UNG, the scale factor is going to be 7 because I'm going to go bigger to get to the bigger shape. And the scale factor from POT to UNG, the POT ones are on top. So the scale factor from triangle POT to triangle UNG is going to be 1/7. So you're always, again, looking for the first word. That's the one that goes on top of the fraction. So for this one, we can pretty much figure out the angles pretty easy with this. E is 106, and that corresponds to H. So because of that, I know that this is 106 degrees. O corresponds to A in the other shape, so this is 85 degrees. But then we're missing an angle, right? And then this is also 64 right here. So the sum of the angles in a quadrilateral is 360. So if we subtract all of these other angles from 360, then we end up with 105. So 105 degrees doesn't look like it's drawn to scale, does it? So the measure of angle A is 85 degrees. And again, we got that from this fact. The O and A are in the same position in the similarity statement. So to find MA, MH, and OV, we're going to use proportions. I'm going to go back to here and say LO over MA. So LO over MA is equivalent to OV over AT. So I'm just setting it all up using that similarity statement. BE corresponds to TH in the other one. And then LE corresponds to MH in this one. So if I want to try to find MA, I'm going to use this ratio. I know I'm going to use that one, LO over MA. But then I have to have it equal to something. So let's go through and see what we have. We don't have anything for OV, but we do know that AT is 2.8. We don't have anything for, oh, we do have something for VE, it's 5, and then TH is 2. So this 5 over 2 is also equivalent to LO. So you pick the 2 in the list that you're going to work with. Only work with 2 at a time. You can work with any 2 that you want to. And then also if I look at this, OV over AT then becomes OV over AT is also equivalent to that 5/2. And then LE over MH, so let's look at what we've got for that. We've got 4.6 for LE, MH we don't know. So LE over MH also equals a 5/2. So now that each of those are set up, let's go and take the actual values that we know for LO. So LO is right here. It's 9, so I'm going to plug in the 9 for LO over MA equals 5/2. The process here is you're going to cross multiply. 9 times 2 is 18, and that equals 5 times MA. So then I'm going to divide both sides by 5. And when I do that, I end up with 3.6 for my MA. Go ahead and do that with the other 2 sides of the quadrilaterals for MH and OV. So if you pause the video and tried it yourself, then you should have gotten 1.84 for MH and 7 for OV. So here's your calculations for each of those. Notice that each of those I'm putting them equal to 5/2, cross multiplying and divide. Now the ratio of perimeters, this is an interesting thing because if you summed up the perimeter of L, OV, and MATH, did you know that the perimeter turns out being just the same thing? So LOV to MATH, the ratio of the perimeters is the same thing as the scale factors we've been using. It's going to be 5/2. Just the same as we did before, and we choose the 5 to be in the top because 5 corresponds to the LOVE. So if you look at this proportion right here, the VE was on top and then the TH. So LOV number goes first, and that became the 5 and the 2 is where we got those from. So here's the deal. Just like the sides are proportional, the perimeters are also equivalent to the ratio of the sides. So here's all of our sides right here, but notice that the perimeters, this top one is the perimeter of ABCD, and then this is the perimeter of JKLM right there. So the perimeters can also be put equal to the sides of the polygons if we want to, if we need to. So here's our two shapes. We're going to figure out what Q, X, Y, and Z are with this. I want you to go ahead and try this one and make sure that you can do it. And then our next problem will be a perimeter problem. So go ahead and try this one on your own, pause the video, then come back. I set up all the ratios of all the sides using QM and P as my top and URST as the bottom. QM corresponds to UR, so there's my proportion for that, and then I continued that with each of the sides. The next line I went and I plugged in everything I know about the sides for these. QM and UR, I don't really know what those are, and I don't really care this time because I want to know about this X over 25. So X over 25 is going to be set up with this proportion of 18/30, but I'm going to reduce that to make my math easier. So I'm going to divide the top by 6 and the bottom by 6, and you get 3/5. So then I end up with 75 equals 5x. And I get x equal to 15. Then I'm going to take that 3/5 again, and I'm going to put it equal to this fraction this time, 15 over y. So 3y equals 75. So y equals 25. And then we need to figure out what z is. So z is right here by the m. There's the m, so it should correspond to the r. There's r at 115, so you should have gotten z equals 115 degrees. And then our perimeter one. We got to find the scale factor of VWXYZ, meaning that the number from this one is going to go on top to this one, and then the perimeter of each polygon. We're going to call this shape 1 and the shape 2. So the perimeter of 1 is what we need to figure out. The perimeter of 2 we can figure out because we just add these together. So you get 7 plus 3 is 10, 6 plus 4 is 10 more, so that's 20. So the perimeter of 2 equals 24. And then we need to figure out a scale factor. So V, if I look at AB, this is the only one with a number on it. So AB is right here, so it corresponds to RS. Here is, we did another one of these with the letters not matching. This is VWXYZ. Sorry about that, go change that. Okay, so back to this. AB corresponds to VW. So here's VW right there. So since I'm doing VWXYZ, VW is going to go on top because it comes first, and then VW corresponds to AB. So my ratio is going to be 6/9, which reduces to 2/3. So this is my ratio, and VWY is also equal to the perimeter of the second figure over the perimeter of the first figure. So now I'm going to take this ratio and this ratio and put them equal to each other. So the perimeter of 2 is 24 over the perimeter of 1, and that equals 2/3. So we get 72 equals 2p. So p, or the second perimeter of shape 2, so the perimeter of shape 2 equals 36. So this one, and it's just units. So for this one, just remember that the perimeter can also be put into a relationship between the sides, and it's equivalent to the ratio of the sides. So these all have the same scale factors. And that's the end of your lesson. Thanks for taking notes. See you in class.